This material was created specifically to make it easier, faster, and more affordable for any businesses or engineers using traditional manufacturing methods like CNC milling or even metal injection molding. Maybe you already have a desktop 3D printer and are looking for more strength and durability from real metal parts compared to the plastic you may be using today. That's where we fit in. We've succeeded many times over with printing, iterating, and designing parts that then got sent out for debinding and sintering, and we've received back beautiful, durable metal components. Your parts designed and you're preparing the model for 3D printing, it's important to note that these parts will shrink anisotropically. For that reason, you'll want to scale your model to be sure that the part you receive back is to the dimensions you're expecting. And here's the proper scaling to make sure that's successful. In order to print with Ultrafuse 316LX filament, your 3D printer will need to be equipped with the proper components. For instance, a heated bed capable of at least 100 degrees Celsius, a glass bed with Kapton tape or Dymafix bed adhesive, and a hardened steel nozzle. Parts back from sintering, and these are full metal stainless steel 316L parts. You can process them any method that you'd like. You could grind for material removal, polish in any method you see fit, or even CNC machine these for higher tolerance features.
Then becomes a 3D model. So in general, you take your CAD model, convert it into an STL, then in the slicer you prepare it for printing. That creates G-code, which is then sent to the printer as instructions to make your part. Debinding, put simply, is just removing the non-metal parts and then, in the sintering process, combining the metal parts into one solid part. Now your part's been debound, it's now what's called a brown part, and it's ready for sintering. Put simply, sintering is just combining the metal particles into a solid part using temperatures and pressures. In this case, it's around 1400 Celsius for 316. Now, this is also where you're going to see that shrinkage, where you're seeing 20% in Z and 16 in X and Y. That is oriented with the print method. So the Z level, or the layers, that's the direction that's going to shrink the most. So it's important to understand the surface and features of our part in the green state. Because it is a polymer-based process, you can sand it, grind it, sandblast it, polish it, kind of get the part closer to the surface quality you want to have before it goes into sintering. Right? And at the same time, of course, it's 316L stainless steel. It can be polished, it can be welded, other things. I'd like to say the interesting part is that it's additive metal. The boring part is it's just metal. You know what to do. Spray paint it, sand it, sandblast it, and treat it to whatever specification you need to your final part.